Thank you. Yes, it is.
Come on down, come on down. There's a lot of space at the front, like the second row here. You can sort of move in. I know, I like it. There's still a lot of space, like in the second row here, so just come and move up. Maybe if there's space to the right of you, then shift down the row so that we can have more people come in this way. So go this way, go this way.
Oh, okay. I didn't see them.
Alrighty, I'm going to get started while the last people find their seats. So please come on down. This is Cloud Native London. We're going to be on Twitter at Cloud Native London tonight. Cloud Native London is a strong, open, diverse developer community around the Cloud Native platform and technologies in London. My name's Cheryl. You can find me on Twitter at oycheryl. I am your host for this evening. So I currently work at Arm, but I've also been hanging around the Cloud Native world for a little while. So you might know me from CNCF. I've also been Google and Apple and lots of other places. We have 3 talks for you tonight. The first talk is going to be what it means to be a platform engineer and some concepts about platform engineering. And then our second talk is going to be Kubernetes, Prometheus, and monitoring in multi-tenant environments. Then we'll have a 15-minute break, at which point you can go grab any drinks. Toilets are in the corner, like on every floor, there's toilets over there. And we'll come back at 8 o'clock for infusing telco networks with cloud native technologies. And then at 8:30, we'll wrap up and go to the pub, which is downstairs. I forget the name of it, but you fall out of the building and it's on your left. So it's really close. Couple of thank you to tonight's sponsors. So where's Richard? Who's going to do? Ah, here you are. You have some slides, so take the stage.
Evening all. Great to see you. Yeah, just a really quick intro on Sysdig. Thanks for having us here. We're a cloud native security company. And essentially we got our start in the sort of the right-hand side of this diagram, sort of solving problems around workload protection and security. But we've sort of evolved into a broader security platform covering things like cloud posture management, identity and access, and cloud detection and response. We basically have a big focus on open source. So we believe the future of security is open. There's a number of different projects that we build upon. Some of those of note, Falco, which is a project which we originally built and donated to the CNCF. That's basically the de facto standard for cloud native intrusion detection. Wireshark from the networking world is our heritage. In addition to that, we build upon things like OPA, eBPF, so basically sort of security policy and deep visibility into the Linux kernel. And basically, if you'd like to give us a try, you can go the open source route, take a look at falco.org, download Falco, take a look at this O'Reilly book that you can get for free, which is written by our CTO, Loris. And should you be interested in the offerings that we have around Falco and the like, then please take a look at Sysdig and give us a trial. And I'll be hanging around. So if you'd like to have a chat about Sysdig, then just give me a shout. Thanks.
Thank you very much. I see there's a handful of people standing over there. There are 4 tall chairs by the windows. So if you want to perch, feel free to come around and sit up here. And of course, our second sponsor for the evening is Just Eat. We are in their offices. So thank you very much for hosting us tonight. Another quick announcement is WTF is SRE conference, which is coming up on the 4th and 5th of May. So you can get a 25% discount on the ticket, and we'll send out an email afterwards with the details for how to get that. All right, a little bit of live polling. So please grab your phone if you can. Go to this link, oishero.com/p. It's not going to ask you to download anything. It's just a web link. And I'm going to ask a couple of questions about you and a couple of questions about how you use cloud native. Okay, oishero.com/p. There is Wi-Fi, but it's a little bit tricky because you have to put in an employee's name and they have to approve you. So apologies. Okay. Oh. Someone wants to burn through all their data. Okay, so you should have a question. Is this your first time at Cloud Native London? Yep, people are already getting the hang of this. It's a yes or no question. Looks like, we're pretty even, 50-50 first timers and return people, which is amazing. I'll give a few more seconds while people join. We also have people joining us on YouTube and on Twitch on the live streams. So obviously feel free to also follow along with the live polls. Oh, yeah, I think we're slowing down. 50-50, very cool, very nice. Second question, what is your job title? Just pick whatever is closest to what you do. So we've got architect, application developer, backend developer, engineering manager, SRE/DevOps engineer, security engineer, or anything else. And the SREs are pulling ahead, or DevOps engineers are pulling ahead today. So as architects, also at 20%. Okay, no security engineers here today, but yeah. Okay, SREs and DevOps engineers definitely pulling ahead strong, showing up strongly tonight. Okay, let's go on to questions which have been submitted by our 3 speakers for this evening. So I'm going to ask you your thoughts as they come in. So first question, is DevOps dead? Yes or no? Comments on what you expect for this question. This is your question, right?
Yes, it's my question. No, I'm agree. I'm agree that it is not dead. Yes, I'm agree with that.
I hope that the people who are DevOps engineers are not answering yes to this question. All right, we have 75% think it's not dead and 25% think it's dead. Very interesting. All right, how many software companies will adopt platform, engineering teams in 2026? So less than 10%, 40%, 60%, 80%, or 100%. Oh, feels like people, 60% feels good. And this is your question, right? So is this what you expected?
For question. Yeah, yes.
Is this what you expected?
Yeah, I don't want to spoil the final slide of my presentation.
Okay.
But yes.
Is this what you kind of expected from this audience?
Yes, more or less, yes. More?
Yes.
Than, more, yes, I expected, no, but more 80% than 60.
Okay.
Yep.
Very cool. All right. Keep going on the questions. What is a citizen developer? A person who knows how to code, a person who is non-IT trained becomes a software developer, or a software developer that is respectful of laws? I can't remember who, is this your question or is it still yours? Okay. What were you thinking with this question?
It's just to be aware about citizen developer. It's correct, the second one.
Okay.
Yes.
Okay. Oh, wow. A person who is non-IT trained becomes a software developer. Is that what the right answer is? Yeah. Okay, very good. 75% got the right answer. You don't want to answer this question? Oh, okay. This one, yeah. Well, let's see what people say anyway. How many platform types exist? Well, so I guess I'll ask, like, what is a platform type?
This is the point. You have platform for infrastructure, you have platform for developers, you have platform for SRE teams, you have platform for no coders, low coders. You are counting, yeah. And I don't remember why I put 7 because I'm sorry, 6 is Uber, Just Eat is a platform, and the last one I don't remember. But there are 7 at the end. If you follow me on LinkedIn, you can check the article. Yes.
See it. Okay, thank you. All right, we have a couple more questions. Question, have you got a multi-tenant Kubernetes environment? Yes, private multi-tenant, soft tenancy Kubernetes inside the company. Yes, hard tenancy. Yes, we provide services in multi-tenant Kubernetes clusters like a PaaS platform, or no? Tell me more. So who's, this is your question, right? Yeah. So again, is this kind of what you are thinking?
Yes.
Yeah. Exactly. It's like, no, but we want to know more. So perfect. Thank you very much. And then I think we have one more question to go. Ooh, approximately how many live 5G standalone networks are in operation around the world? Oh, you got anywhere from 0 to thousands here. It's a big range. Where is Richard? Okay, let's just see what people are answering first. So very even. Like people say there is 5G, but otherwise have no idea. That's what I take away from this. Is this what you, what's the answer?
Thank you very much. The best data available is around 40 to 50. So most of the 5G that you're using these days, it doesn't have a 5G core yet. So I'll reveal what that is in my talk. Thanks.
Ooh, thank you. Sweet.
That's a
Yeah. Thank you very much. Thank you for taking part in the live polling as well. That concludes that section. I'm going to take a quick selfie for the purposes of social media. So please smile and wave. Thank you. And if you want to come up and be on this stage as well, please go to cloudnativelund.com. We're booked up for speakers until next year, but you can definitely come, you can sponsor, you can promote your events as well. So just plan ahead, cloudnativelund.com. And that is it. I'm now going to hand over to our first speaker. So round of applause, please.
Also this one, and also this one. Okay. Thank you very much. Good morning, everybody. No, good afternoon, sorry. Good evening. At the end is good evening. Okay, today I want to tell a story about platform engineering, internal developer platform, and what does it mean today, platform engineering. From my point of view, it's a story. I created a lot of slides, just more or less 120 slides. I think I have enough time for 100 slides. Yeah, but it's just an animation. Let's start with the first one. You know that the developer team are writing application. Yeah. And more than one developer team may write more than one application, and they can write a lot of application. That's it. It's very easy. And what happens that applications usually share common aspects like infrastructure, pipelines, code repository, configurations. half of you are operations people, SRE people that are working for application developers to create infrastructure, to keep the infrastructure up and running. And sometimes that infrastructure is a multi-tenant infrastructure. And these common aspects at the end is a product for the developer team. Then we can call this product a platform. Then a platform is a way to share common capability among several different developer teams. It's very easy as a starting point. You understand why I have more than 100 slides now, because it's it's just an animation. Then where people, at the end, a platform is where people, teams, organizations are sharing value to create applications. And the application is creating value for the business, for the end user. And we have two kind of personas, we can say. One are the producer of inside the platform, the developer teams that are creating from scratch a library, a container, an infrastructure, a data products, an event. Then create something that can be reused and consumed by consumers developer team. Consumers then use infrastructure created by producers, can reuse API created by someone else, can reuse data products created by the producer teams. And now we have someone in the middle, because the platform is at the end is a product, and you need to manage that product. When we have producer and consumer together, they work together to create application, because producer crafts libraries, containers, API and data products. Consumers reuse and compose that in a simple way to create application. Let's do an example. This producer team can create a payment gateway, can create a product catalog, can create a shopping cart. And the consumer team can compose in a flow your user experience for buying something from the catalog. The catalog, the pricing model, the purchase flow using the API gateway the payment gateway produced by the producer on the side, on the left side. And then together they created the application. And the payment gateway can be reused more and more than one time. If you pay via Satispay, PayPal, Scala Pay, Apple Pay, it's the same capability that can be reused by several different applications. And who is in charge to manage the platform and provide the capability to share commodities between the two kind of teams is the platform engineer. The platform engineer creates the value between the produced by the producer and consumed by the consumers. At the end, it simplifies the life of people. Then it's like also Justit is a platform, Also Airbnb is a platform. With the same concept, you can visualize the platform inside a company for creating software in the same way. You have people that creating from scratch new capabilities, people that are composing that new capabilities to create an application, and people that provide commodities, share value in common infrastructure. Today, I want to go through the customer journey from both of them, from producer and consumer. Let's try to another important part that is missing the arrow, because here there is an arrow, the direction of this part. Sometimes consumers can compose something that can be reused by producers, and in the feedback loop create more and more value. Then is missing the arrow. I'm sorry, but the arrow is like this one from that side, and then produce and provide value. And the platform is the way you exchange value between people. What a platform engineer is, and which is the role of platform engineers. This is the key point of today. Let's try to understand better using a customer journey, using a storytelling. I would like to visualize with you in 10 minutes, which is the life of a team in the journey to creating an application in a cloud native way. Let's start from the first one. How many person, please raise an hand, are provisioning infrastructure for your colleague, your teams? How many people? Okay. You are the personas of this customer journey. You want to provision some infrastructure to your dev team. You can ask to the platform, create infrastructure, and the platform provide you a way to automatize this. Instead of creating Terraform scripts and copy the Terraform scripts, the platform creates for you in automatically runtime infrastructure. I put in here some example, Kubernetes, but can be GKE Autopilot, can be Azure Function, whatever. Is a runtime infrastructure where your workloads can run. Provide auto-scaling policies. You have to figure out how to create a network policy. Maybe you have to configure a common a content delivery network, a CDN. Maybe you have to create also data storage for data store, NoSQL, SQL, bucket storage, data stream. It's something that people ask you every day when they have to start a new projects. It created for you also the monitoring part. And after we speak about monitoring, Grafana, Prometheus, alerting system, it connect for you FluentD, FluentBit. You also set up something to manage the cost for your infrastructure. Okay, this is a customer journey. Are you happy if there is a platform that for you create everything in that way, and you are focusing on create the value for your teams and not just having to create every time something, thinking about the policies or the templating system that you need to implement this part. This is a self-service approach. You as a developer or operation team, and you provision an infrastructure. In that way, you can focus on value, and you can say to your team, start the project today. Now you are we start the project. Always there is a platform in the middle. Remember, platform is where people share value, where people are, a platform provide the capability to create a self-service way to interact with your software artifacts. Then as a developer team, I want to code a web application. I want to create a web application. Then first of all, I create a project. Then the infrastructure is up and running, but I want to connect your Git repository. Maybe you want to connect GitHub, GitLab. You want to create pipelines to create your software artifacts, to create your Docker images, to test your application. Then you need a DNS, you need a SSL certificate if you want to expose API to the web application. If you are in Kubernetes, you need the namespace for running your application, network policy correctly configured. Then you need the login, monitoring, alerting, and tracing. And you need to connect to the data store. Maybe you have a multi-tenancy approach for bucket storage, data stream, I don't know. It's something that the platform creates for you, and you have just to focus on coding. Also, if you want to focus on wiki to create, to track your architectural decision, to share your knowledge, a product backlog, matrix, a lot of things that help you to focus on coding, not to focus on creating the common place where you start to code. Then it is just an idea. If as a dev team, you can create a project and start from scratch very easily in just 1 minute, have everything just up and running, you can focus and code, start to code and test and deploy your application. Let's try to deploy the application now. If you want to deploy, you can ask a platform, please deploy this application. And the platform trigger orchestrates something like versioning, testing. If it is the platform, at the end, the platform is up to the platform engineer to configure the policy. But if the platform say, okay, to deploy something, I have to verify also the open source license. It verify also the open source license. It verify the dependency. You do static code. Nobody here is a security engineer, but you need also security in some way. Static code analysis, dynamic code analysis. build the Artifactory, promotion the build, create a manifest, apply the manifest, deliver the application to the infrastructure, audit log about the application deployment, and then it's not finished because you have to verify that the application is up and running correctly. Then connect to your health status of your application and say, okay, is running correctly or not. Now you can start to proactively monitoring your application because it's something that is not in your duty. Everything is automatic and you have just to focus on the monitoring of the application. What does it mean? As a dev team, I want to check the application status. And how I can check the application status? The platform can provide you access to logs of your workloads in real time, metrics of infrastructure usage, but you can provide also application business metrics. How many items have been sold in the last minute? How many transactions have failed? Is a business metric, and it's important that in the platform you can visualize the business metric of your application. Application analytics, how many users are using your application, how they are using your application. Alerting, how many alerts, how the history of them, the threshold and fine-tuning of alerts is important. You can trace also the call between microservices, for example. You can verify your posture of security. You can check the status of your application time status. You can measure also the SLI. Also, and last but not least, having all of this data, you can do a proactive analysis of your application and do a prevention of incidents. You can proactively act on top of your application, improve the application, preventing incidents. What does it mean? That if you have everything up and running, you can sleep well. You don't wake up during the night and say, okay, there is something that doesn't work. But sometimes happen, sometimes you have to wake up during the night. And when you wake up during the night, I speak for me, I'm not so confident that I have already everything is in my mind correctly. Then I need a support, and the platform can help you to troubleshooting. What does it mean? Focus just on the problem. Then the platform can provide you, for sure, the alerting messaging. It can phone you if there is a problem. You can visualize the dashboard loggings for your application in the correct runtime environment. You don't have to look at where is the server, where is the account, where is the application is running, but the platform provides you the correct path to access to the problem directly. Just I receive a message, click on the message, go in the logging. Update the status page. I can automatically update the status page for the customers and say there is a problem, outage. We are looking at this. Another big important problem is access to the correct source code that created that problem. Debugging, then you can report the incident, do a problem management, update your SLA and status page. These help you to solve the issue very fast. And you can focus on the issue and not focus on the process because everything is up and running for you, is already on the platform. Then I want to optimize the application. Optimize that, what does it mean? I can read the review about my application, then the rating from the store, from Apple Store, for example. I can measure technical depth, DORA matrix. I can do stress performance test, classify application behavior matrix. I can fine-tune application infrastructure parameters. I can shut down not necessary runtime environments. I can perform experiments using chaos engineering to improve the reliability of the application, and can put everything inside analytics and try to find out some insights about metrics. This helps me to continuously improve the application. Now I can, as a dev team, I'm happy about my application. It's working very well. I want to share my knowledge with other teams inside the organization. Then I want to share. And the platform helps you to share also. Share your library, share your API products, share inside a catalog. You can share a lot of information and provide the documentation about that. And at the end, monitoring the usage of what we share. Because if nobody uses what we are sharing, is useless. You can drop out and understand why nobody is using your application, your library, your events. And from the other sides, you have people that want to reuse your libraries, want to reuse your API, your data products. And thanks to the platform, you can go and check the catalog of items, look at them, self-service tryout, and do a consumption of the items, collaborate to improve the items, and having an upgrade support. If there is a new upgrade, a new minor or major version of the library, of the data products, I am alerted by the platform. I have a support to upgrade that. In that way, you create your journeys. The point is, does exist a platform like this one? Maybe no. It's still ongoing. But are you happy if you have a platform that solves all of that problem in just one single product that is up and running for everybody and help you to provision the infrastructure, deploy application, check application, solve problem, optimize application, publish items, consumer reuse? Then what is missing in the customer journey? As a platform engineer, I have three main objectives. First of all, improve the developer experience of everybody. Keep software infrastructure quality high and favorite collaboration among people and teams inside an organization. This is an important part because at the end, software is a collaboration, software is communication. Then if you communicate well inside the organization, you can share software, you can share assets, you can improve your processes, your application. Otherwise, it's a problem. And platform engineers also focus on collaboration. This is my opinion. This kind of platform in the market, starting from the 2021, has been called internal developer platform. Okay, this is a term that is rising just in last year. And if you want to go in detail what is the internal developer platform, you can check the last slide about some link. Just a summary about internal developer platform. This is the life cycle of your application: code, shipping, run, operate, and team collaboration. That is the same of developer journey that we see before. And you can connect, you can use several different open source tools to solve and simplify these activities. I think that you recognize some of them are from the incubated, from Science. Some of them are incubated from the CNCF Cloud Native Computing Foundation. And if you want to provide a way to have a customer journey, a developer experience, very easy to, you have to put on top of an orchestrator, something that helps you to orchestrate several different tools to provide something that is much more easy instead of a technology. The life cycle of application, starting from the 19th century, is always the same. You code, you ship, you run, you monitor. It's always the same. It's changing the technology, it's becoming more and more complex. But the point is that you code something that someone else is using. And the idea is that if you orchestrate and put on top a way to orchestrate your control plane and your tools, you can call it internal developer platform. And the access to the internal developer platform can be done using a command line, using a user interface, using an API, or all of them. I have some experience about adopting internal developer platform and platform engineering companies before they call platform engineering. That is, I think that this problem is since 2010. We have the same problem. do more with less, speed up time to market, reduce cost. And the idea of platform engineering, internal developer platform is the same. Improving collaboration, improving quality, providing a common place to work together is important, but you cannot start with a big platform like this one. It's not so easy. You can start, my suggestion, my tips is start small and extend gradually. Don't waste time to choose the correct technology, but try and do a try and error feedback loop. And the important part is if you want to provide a way to share knowledge, it's important that to adopt an extreme programming tool, technique that is the way that everybody share the code, they share the source code. And in that way, if you approach it as an internal open source inside your company, then everybody can see the code and can improve the source code from someone else's in a good way. And internal open source model is a way to create a collaboration inside the company and to simplify the creation of a platform inside the company. Last but not least, depends of your size of the company, how many people can be dedicated to the platform. You may choose between make or buy or in the middle. Maybe you can buy something, you can make something else. Depends, it's up to you. The important Agile and Jira, you know, if you buy a Jira, you are not Agile. If you buy internal developer platform, you create an internal developer platform, you don't create nothing. You have to change no, it's not correct change. You have people that are motivated on this and try to measure the benefits always. Otherwise, it's just a tool, another tool on top of other tools. The question about before how many people is not mine, is from Gartner. From Gartner, 80% of large organizations, software large organizations will adopt the platform engineering, but 70% of large software engineering organizations will obtain less than a desired value from their platform engineering effort. Be aware about that. It's true because, you know, it's not easy. It's like DevOps. When you adopt extreme programming, it's the same in 90s and DevOps came in 2010, but it's always the same from my point of view. Agile is always the same. The point is streamline the software development, and it's not enough just add a new tool, a new term, say platform engineering, and solve every problem magically. If you wanted to know more about that, you can check on our website. We have a page with all open source tools, all blog posts about platform engineering around the world, all tools from open source or not. I don't know if it works because there is talking on top, but it's fine. Thank you very much for your time, and I think that we are in time, yes? Okay. Yes.
And any questions? You can use that same link before, the polling one, oishell.com/p, or you can use this longer one up here if you forgot that one. So we'll take a couple of minutes and see if there are any questions. Okay. If you prefer to talk, I also have an orange cube I can throw at you as a microphone. Bigger than this? Oh, okay. Okay.
With no
So,
question, that means the speaker has explained it really well.
it's true. I thought it was really clear. Yeah. Okay. All right. Thank you so much. Again, round of applause, please. All right, one question. One question. There we go. Oh, you answered that one.
Thank you. Is platform engineering just a modern term of system? I don't know what these system engineers. Is system is IT system? I don't know. I'm not able to answer. System. Please help me. What does it mean? System engineer. DevOps. Predated DevOps. Okay. It's difficult to answer. From my point of view, SRE, DevOps, platform engineers, operations, everybody together create a team of platform engineers. You know, the idea is that is extended. No.
We'll take this as one question.
Yes, one.
Talk to you once.
What?
Is DevOps dead? What's your opinion on this?
No, it's not dead, but DevOps is not a role, is a practice, is a method of approaching the delivery of software. It's not dead, like Agile is not dead. Like extreme programming and test-driven development is not dead. You know.
I agree with you for the record. All right. You're going to stay around for the rest of this evening, yeah? So please follow up with any questions. All right. So I'm going to move to the second speaker now. Saeid, you ready? Okay, round of applause, please.
All right. Let me see what we have here. Okay. I'm going to talk about Kubernetes multi-tenancy and multi-tenant monitoring in Kubernetes. And let's see what we have. Our agenda is to define what is the Kubernetes multi-tenancy. After that, the definition of multi-tenant monitoring, and looking to different solution that we can implement inside Kubernetes to achieve multi-tenant monitoring, and use Prometheus multi-tenant proxy server to implement multi-tenancy for Prometheus. And after that, see what is the type of segregation in multi-tenancy, and implement a live demo for multi-tenant monitoring in Kubernetes. Okay, what is multi-tenancy? In the term of multi-tenancy, we have two types of multi-tenancy in general. Soft multi-tenancy and hard multi-tenancy. And it means in a soft multi-tenancy, you live in the same house, in the same home, but in a different rooms. And what does that mean? It means something will be shared. For example, kitchen, toilets, and corridors, and all the ways will be shared. And you just have your room, and just your room is private and is belong to you, but everything will be shared. In a hard multi-tenancy, you live in the same building, but you have your own flat. And many things in that case will be private, and it's just for you. And in Kubernetes, you can implement both of them at the same time. When we talk about soft multi-tenancy in Kubernetes, it means some or maybe all resources will be used in a share mode by all tenants you have. API server, worker nodes, ingress, storage, monitoring, logging, GitOps, backup, restore, and etc. And when we talk about hard multi-tenancy, each tenant has their own dedicated resources, or they can be on dedicated platform, or maybe in a shared platform. It depends on the design. And it means your tenants will be deployed into separate clouds, separate environments, separate cluster, separate virtual clusters, and it depends on the design. And the thing is, when you want to decide, okay, which one is the right choice for our environment, for our company, you should ask who deploys what, and who manages what, and who responsible for what. And today, if you ask anyone, okay, we want to implement an infrastructure or maybe environment to deploy our application, they say, okay, use the Kubernetes. And Kubernetes is the answer. But what was the question? You need to back and check what was the question and what really you need in your environment. And based on that, implement your infrastructure. We have many concerns about implementing multi-tenancy, but right now I'm just want to talk about monitoring, because in the case of multi-tenancy, we can talk more than one day about just the multi-tenancy definition in Kubernetes, because for each need inside the Kubernetes, we may have multiple choices and multiple solutions. And right now, we want to talk about multi-tenancy monitoring, just the monitoring inside Kubernetes. So soft multi-tenancy for the monitoring means use a unified monitoring system to monitor all tenants, create proper index or labels, it depends on the solution, and manage their access through strong authentication and authorization and implementing the RBAC. And the pros of implementing the soft multi-tenancy is you don't need to manage thousands of monitoring instances and thousands of monitoring systems. And another one is it's a resource and environment friendly, because you have a one unified monitoring system and everything will be stored in that unified monitoring system. And you can manage everything in one place. If you want to change some configuration, because it's a unified platform, you can do it. And the cons is no self-service or on-demand configuration for the users. Your user cannot come to the platform and change their configurations, because it's a unified system, and as a platform team, you have to manage it. No or minimum customization capabilities, needs more complex authentication and RBAC system, and hard to implement chargeback. If you have, deploy your infrastructure as a platform team, and you have a multiple project team that you have to charge them based on the chargebacks, in the soft multi-tenancy, it's really hard to implement. In the case of hard multi-tenancy, it means you need to deploy the instance of the monitoring system for every single tenant. And in that case, every single tenant has their own monitoring system. And they can access to their monitoring platform, just like admin user, and do anything and use anything they want. And the pros is it can be customized by your user for every tenant. You don't need any complex authentication and RBAC system. It will be self-service and with an on-demand model. And chargeback is really easy to manage, because every tenant has their own instance, and you can charge them based on the storage that instance consume and the resource that instance use inside the cluster. And the cons is need more work to keep version and configuration in sync. If as a platform team, you want to implement the hard tenancy model for the monitoring, and you want to keep all the instances in sync by some global configuration with the same version of that instance, it's really hard to sync. And in shared clusters that you need to provide hard tenancy of monitoring system, you need some restriction to prevent conflict and information disclosure on tenant applications, because it's a monitoring system. And in the case of Prometheus, we will see what really happened. And it's a resource killer, because for every single tenant, you need to deploy monitoring application. Now, the true story is when you do your job, you say to your boss, okay, almost ready. After some day, yeah, your boss like, okay, let me guess, even more almost than yesterday. And you said, yes, much more. Because every time you need to improve your infrastructure, your application, and everything you have in your environment. And that job that none of it will be done, and DevOps is not there. Okay, it's me, Saeid, and right now I'm a Kubernetes platform engineer at the CBRE. And in a CBRE, just to get the what really we do, right now we are working on creating a multi-cloud, multi-tenant, multi-project, multi-user, and every multi we have in the world in the same project. And right now we have more than 500 clusters, and it's with more than 12,000 worker nodes. And it's really, really big environment with 12,000, maybe more or less, project team that working in different environments. And because of that, we find that, okay, we need some multi-tenant solution for monitoring. I'm just talking about monitoring today because for all the cases, we had many issues and many concerns about multi-tenancy in such a big environment. And right now, we're gonna see how we implement multi-tenant monitoring inside our environments. When we want to implement Prometheus and use the Prometheus, because the Prometheus right now is a best practice to monitor Kubernetes environments. When we want to deal with multi-tenant model and implement multi-tenancy, we can create a multi-cluster architecture. It means for each tenant, we can implement multiple clusters. And in the case of monitoring, we can deploy one instance of Prometheus inside that particular cluster and provide access to project team and say, okay, this instance is for you, this instance for you, that instance for you, and you can use your own Prometheus monitoring system. And behind the scenes, we can send all the metrics to one Prometheus stack that belong to our team. And with a remote write, or it depends on your method to use remote write or remote read inside the Prometheus to store all the things and read all the metrics from another Prometheus instance and store it in one Prometheus stack that belongs to product team or platform team. This is the basic solution you can implement. Another one is to architecture Rancher currently provides. You can implement and deploy cluster level Prometheus. You can deploy project level Prometheus, and you can deploy namespace level Prometheus. And in this case, you can deploy and you can implement the multi-tenancy. But the issue is you have to deal with all of these Prometheus instances, because all of them is a real instance. And if you want to collect your metrics, it should be go there, here, and here. And you need to store all the data 3 times, because the solution is based on deploying Prometheus in multiple levels. And this is another design. Another design is to implement, this is one cluster, and inside that cluster, we have two tenants, for example, tenant 1, tenant 2, and tenant 1 right now has 2 namespaces, tenant 2 has 2 namespaces, and if they provide proper labels in their pod, inside their deployments, inside their ingress services, and all the Kubernetes resources, Prometheus can collect all the data. And after that, by using the Prometheus multi-proxy server, you can provide and implement the RBAC to provide access to the tenant 1, and the tenant 1 can just make a query on their environment, on the namespaces, and the tenant 2 as well, without deploying multiple instances of Prometheus. With just one Prometheus, all the data to provide granular access to tenants. This is another design you can implement. Another one is to provide some abstract layer called project. And in that case, again, it's a one cluster. And you implement some abstract layer by using Kiosk, Loft application, or using vCluster, another application from Loft project, or by using anything, you can do it. And in that case, again, instead of namespace label, all resources should provide project label. And in that case, Prometheus multi-tenant proxy will be able to provide granular access based on the project, not the namespace. And in that case, if user try to make a query on their project, they can get the information of both namespaces together. But in that case, it's completely different. Another solution is to implement something else and running the Prometheus multi-tenant proxy server in a chaining mode. In that case, you already have one instance of Prometheus, and in addition to providing namespace level metrics and adding namespace label, you need to provide project label as well. And in that case, your user and your tenants can make some configuration for providing some access to their teams. And in that case, for example, you provide one access to tenant A, and the tenant A may have multiple namespaces for dev, for prod, for non-prod, for UAT, and all the environments. And in that case, their lead DevOps or the project manager wants to provide a limited access just for the dev namespace or non-prod namespace to developers, and provide more access to DevOps engineers. And in that case, you can run your system in a chaining. Or you can use the Cortex model and implement some complex environments by implementing multiple clusters. And in that case, you have one Cortex instance, and that Cortex instance will collect Prometheus metrics, and all the Prometheus metrics that's currently collected inside that particular cluster has namespace and project labels, and top of all of them, you have Prometheus multi-tenant proxy server. And again, you can create a chaining mode and run complex or create any complex design and architecture. Now, what is the Prometheus multi-tenant proxy? Prometheus multi-tenant proxy is an open source tools that we developed in our company, that you need to connect it to main Prometheus instance. And in that case, the Prometheus instance does the job without changing anything, just like before. Right now, you may implement and use Cube Prometheus stack, Prometheus operator, or any Prometheus instance inside your Kubernetes cluster, and everything is created by the Prometheus just like before. And after that, by using the Prometheus multi-tenant proxy, you provide a configuration. Okay, I need the project label, and this user one, should access to tenant 1 project, and user 2 should just access to tenant 2 project. And in that case, when the user try to create a query, for example, up, it sends to Prometheus multi-tenant proxy. And behind the scenes, Prometheus multi-tenant proxy inject one label, it depends on your configuration, to that particular query. And by using this method, the user can just get the information that has that project label or namespace label. It depends on your configuration. It's really simple, but when you want to design your architecture, it really matters how you deal with the labels, because it's related on the labels, and you should provide a proper relabel config inside the Prometheus to read the namespace, read the project, or any other labels. Okay, let's see what we have here. We have a Kubernetes cluster up and running here. And I just deployed a Prometheus inside Prometheus namespace. And if we see what we have here, the deployments, we have one Prometheus instance, we have a Grafana, and we have a Prometheus multi-tenant proxy. And if we check the configuration right now I provide for the Prometheus multi-tenant proxy is one user for the Cupra. It doesn't matter right now. One user Earth and one user Moon. And I want to create a multi-tenant monitoring system based on the namespace, and Earth user can just collect and make a query on the Earth namespace, and Moon user can just query everything inside the Moon namespace. And right now, if we go to our Grafana and see data sources, for the admin, we have our main Prometheus, but for the Earth project, we have to point to multi-tenant proxy. And if I go to explore and, for example, check as an admin level, I need container, for example, memory usage, and run the query. You can see we have all the namespaces because it's admin user. and all the namespaces about Cube system, Prometheus, Airs, and we can see as an admin user, you can collect all the information and without any restriction. But if we do it for by using the Prometheus multi-tenant proxy and by providing Earth user credentials, you can see you can just collect and query all the resources inside Earth namespace. By the same command, without changing anything, you implement multi-tenancy based on one instance. And if we want to do it for Moon, it's super easy. We need to create a new data resource. We need to get the service name, Prometheus, multi-tenant proxy. For the basic authentication, username is a Moon and password is a Moon. And I have to add a custom header. And we said, okay, the custom header is X namespace name. We can put it here and we can provide, okay, I'm from Earth. And then you try to do that and get back to explore again and go for container. You can do that because right now we tell we are in, we want to log in with Moon user, but access to Earth user metrics. For example, memory usage, and then run it on Moon. Let me save it here. The name should be Moon. See, it shows you the username and password again, and you can't do that because right now you log in as a Moon user, but you try to access Earth metrics. But if you go and change it to, okay, I'm Moon. Now you're able to get your information and run the query. And right now there is no any metric for that user because there is no any namespace called Moon. And if I create the namespace Moon and deploy something inside that namespace, create deployment, for example, Nginx with Nginx image, replicas, for example, 2, and in Moon namespace, after 15 seconds, you can see, okay, right now we have something in Moon namespace without changing the queries. And right now, by using this method, we implement the multi-tenancy and without touching any dashboards that you can find in Grafana marketplace. And just we tell our tenants, okay, you can use anything you want without any change. And behind the scenes, by using the multi-tenant proxy, we inject a proper label to all the queries and run it on the main Prometheus stack we have. That's it. Yeah, okay.
Oh, looks like we have some questions already. So
Yes.
we just start. So first one, metrics should be either democratized or hidden. Is it worse to see it and not be able to access it?
Nobody can see and nobody can access when you don't provide any access to them. You need to create a user and you need to provide access. Okay, this user can just access this label. And behind the scenes, the Prometheus multi-tenant proxy do all the things for you. You don't need to do anything.
Are there any standards around project labels?
No, it's based on you.
I'm going to ignore this one. And thank you. Someone is asking about another Kubernetes meetup. Outrageous.
Yeah. Yes. The next meetup will be 10th of May, and I will publish it through my LinkedIn. Yeah. Does proxy server stop working if Kubernetes is a module chain? No, we didn't see any issue because it has nothing to do with Kubernetes. It layer on top of Prometheus. We deployed inside the Kubernetes, but it has nothing to do with Kubernetes.
Is there any way to access all metrics via the same endpoint as?
Yes, yes. As I mentioned, if you log in with the admin user, you can do it. Or I have to share my desktop and show you how it can be happen. But in an access list, you can create a user. Okay, this is the Moon Earth user, and it can access to Moon and Earth namespace at the same time. Or if you want to merge all the metrics together, you can make them in a and you can assign them into the same project. Instead of namespace, you can assign them to the same project.
So we'll do the last question because this is getting lots of updates. So why are we using multiple Prometheus? Why can't we create one named Prometheus and allow the rest of the tenants to access?
To access all the things? Yes?
Yes.
Yep. Then it's not multi-tenant. Imagine you have multiple teams and no one should access to other tenants' metrics because everyone can, when you in a public mode, imagine you provide multi-tenant Kubernetes environments for multiple teams and they have nothing to do with each other. And right now you need a monitoring solution and you need to provide monitoring solution for your tenants. In that case, no one can should be able to see other tenants' metrics. Cortex and Thanos, Cortex cannot do that because it manages the resources, the metrics with at the organization level, and you can't design the Cortex based on labels, and in multi-tenant environment based on the Kubernetes, it cannot do anything for you. But as I said in my architecture, if you have multiple clusters, you can use Cortex. In the case of Thanos, it's the same.
Okay, I'm going to wrap up there because we're going in, but round of applause for Saeid. Thank you. If you have more questions as well, you can always grab him. We're going to have a 10-minute break now. Come back at 8 o'clock for our third speaker. Thank you so much. Hi, welcome back. Please come and sit in for our third speaker of this evening. I'll take off my screen share. Come on in, please come and sit down. If anyone could see where the light switches are for this, then let me know, because I'd like to turn the lights on. All right. Come in, come downstairs. All righty, we're going to kick off now with our third speaker, Richard. So round of applause, please.
Good evening, everyone. Good to be here. Different kind of audience than I'm used to, so I will try to adjust my style to suit you. I'm Richard Kilmurray. I'm part of the network strategy and architecture organization within Vodafone. And in this organization, we define the strategy for the evolution of Vodafone's networks over the next few years. So one thing that's happening with the networks in the near future and already happening in certain contexts is the introduction of cloud-native technologies to traditional telco networks. So I'm going to explain how that happens. First of all, by giving you an overview of telco networks, so you have some familiarity with them if you don't already, and then dive into some of the particular use cases where it's happening. So what you can see, oh, and I should point out, I'm talking about the use of cloud-native technologies within the network itself. They're already extensively used in the IT platforms for the more customer-facing systems. So this is within the network. What you can see before you is Vodafone's network map. It's publicly available on the network and shows the global footprint of Vodafone's main backbone network. It's a combination of the autonomous system 4445 and autonomous system AS1273 in the majority. Other maps are available, such as the excellent telegeography map. So what are we seeing here? Most of the dots are major points of presence in the network. So these comprise big routers. If you've never seen one of these, they're big rack height, hulking things, make a lot of noise, switching and routing not hundreds, but many terabits per second of traffic. And they are aggregating traffic from around the network and connected up by all the links you can see here that are made through fiber optic networks mostly. But there are also other interesting ways the network can be accessed, such as you can see some satellites here. So that helps remote regions get access to the main backbone of the network. There's already some complexity here. So first of all, there are two types of network here. There's a private network, MPLS network, and a public internet platform. Big companies and many organizations are not yet comfortable with routing all their traffic over the public internet. So you have a private VPN network for them. And other customers are. So there's a public internet platform for them. That's the AS1273. Other big telcos and big organizations, like many of the tech companies, have a similar network of this scale or bigger. So another thing that's happening, but difficult to show at this level, is the peering between the networks. So all these ASs link together at internet exchange points, share routes and traffic, and the cumulative effect of that is the overall internet backbone enabled by services such as network time protocol, DNS, etc. So that's the big backbone of the network, not too affected in the near future by cloud native technologies, I don't think. But I'm sure that someone will tell me I'm wrong and they'll crop up somewhere. What's not shown, though, is how customers get access to this network at this level. So these are the main arteries of the network, if you like. But if you zoom right into one of these points of presence, you'll see there's another layer of network around there that links into smaller locations, such as towns, villages, etc. This can comprise the radio access network. So all the cell towers that you have around you and you gain access through your mobile phone, and also fixed networks. So that's your broadband at home. Could be either still copper, maybe fiber, different standards like the Broadband Forum and Cable Television Labs provide those methods of accessing the network. So around all these dots, it all fans out into hundreds of thousands of access points, impossible to show neatly on a figure. Also within that, there's another aggregation layer. So you go from hundreds of thousands typically to thousands to these points in the network. Then other things that are plugged in are, say, data centers, as we all know, the big public cloud providers like Amazon, Microsoft, and Google, TV broadcasting services, and many other organizations also have peering with the network. Big companies have their own data centers connected too. So lots happening. Already, there's lots of things to take into account when you're managing a network of this scale. So if you think about the scope, there's always things changing. Some things change very slowly. So say the major points of presence, they change. They're very settled in many locations. So where you've got big routers, say in New York or Morocco, they're pretty stable now. You might get a new point of presence appearing now and again. Changing at a faster rate is the actual equipment on that site. So these go through a technology evolution. The big router becomes a more efficient and hopefully lower energy consumption router. Then in the intricate parts of the network as well, that equipment is also going through a technology evolution. And that technology evolution cycle is something that enables us to inject the cloud native technologies. The network generates a tremendous amount of data, as you might be able to imagine, and there are always problems in the network. So they could be small, say there's been a power failure to a mobile cell site, or could be big, like a natural disaster. So the network as a whole is designed to be resilient to automatically reroute around any big failures of that nature. And we have systems to capture all that information, understand how the network's working, summarize it, and present it to colleagues in a network operations center. So a big room with lots of people sat at desks, screens with dashboards, alarm lists, etc. Much of that work is now automated. So that is the network as it currently stands. Hopefully that summary makes sense. Now I'm going to move on to discuss the cloud native bit. One of the things that connects into the network is the mobile core. So this is for each country, usually, can be bigger, will have multiple national telcos, 3 or 4. They'll have their own mobile network. That mobile network will have something called its core, which is basically the cerebral cortex of that network, does all the intelligent stuff. So when you're using your mobile phone or other device, that core is responsible for connecting, establishing connections to it, authenticating your connection, dealing with the situation when you move from cell site to cell site, etc. So back to my question. I'm going to explain the 5G standalone situation now. This is a very bare bones architecture diagram from 3GPP for the 5G core. All this, again, publicly available if you're interested. thousands of documents. Maybe you could use one of the latest chatbots to summarize it for you. The 5G core then. This hasn't appeared in many places yet, around 40 to 50 public active live networks. There are obviously more proof of concept networks around there. But the key points around this are that it has a service-based architecture. Each of these things ending in F is a network function that does something important for the 5G core. It expresses certain service-based interfaces. Now, it's designed to be suitable for a dynamic service-oriented infrastructure. So the way the 5G cores are being deployed in the near future is that each of these network functions will be a workload in a Kubernetes cluster. So for each F, imagine there's a Kubernetes cluster. So already you're thinking about having a lot of Kubernetes to manage. Then there'll be geo-resiliency. So there'll be multiple sites like this in every country to cater for situations where there's a big infrastructure failure. So again, even more Kubernetes clusters. Then each of these network functions is going to experience very strong high demands. So hundreds of thousands or more subscribers, all requesting services from the interfaces exposed by these network functions. So this puts some really specialist demands on your Kubernetes clusters. For this reason then, certain standards are needed for the 5G core from Kubernetes. So there's a lot of work happening in the industry now to make a standard reference architecture for Kubernetes that network providers can be confident in using, and the network function developers who are busy decomposing their clever but monolithic technology to run the clusters, they can be confident that their network functions will actually perform as needed in Kubernetes. So myself and colleagues doing lots of work in that area at the moment. Then, along with a high performance Kubernetes environment, we need lots of plugins from the cloud native environment, cloud native community rather. So for example, CNI plugins, we almost always need more than one interface on these network functions. So we need CNI plugins. Standard Kubernetes load balancers just would be blown away by some of the demands that these network functions would get. So we need custom load balancers that, again, like say MetalLB, have been developed by the community. So that's really useful and appreciated by telco operators. Then we get into the specialized behavior of these network function applications. As the developers of these network functions become confident and fluent in Kubernetes, we expect to start seeing operator extensions, and indeed do in certain cases. So we extend the Kubernetes control plane to allow the application to be monitored in a more efficient way and its resources requested in a declarative way. So lots of big developments happening in the world of Kubernetes and telco network functions at the moment. So over the next couple of years, this will be going live around the world. I've focused on the mobile core, but I should say this is happening in other parts of the network. So to give two other examples, you have your broadband network at home. Your traffic gets projected back to something usually called a broadband network gateway. Again, that's a big device that aggregates the traffic and then transposes it where you need it to go, usually the internet or it could be, say, a content delivery network, cache, or something of that nature if you're watching TV. So again, those big functions are going through the Kubernetes lifecycle. They have something called control and user plane separation. All the intelligence is held in or the bulk of the intelligence is held in the control plane. That could, say, go into the cloud, either a private cloud with a telco or a public cloud, and the user plane, which needs to really be able to rattle through that traffic as fast as possible, could still be on specialized infrastructure. So that's out there, and that's undergoing the transformation to a Kubernetes network-based network function. Other areas include mobile edge compute that you might have heard of, where you put compute around the edge of the network, and that's used for certain use cases like gaming, and can provide low latency communication for gamers. And last but not least, there's also Open RAN, which you may have heard of. This is disaggregating the traditional infrastructure for the RAN and putting the software for the RAN to run on more commodified compute hardware. Obviously, there are many cell sites around, so there could be lots of Kubernetes clusters in a few years all over the place, just out in the natural environment. So lots of Kubernetes being injected into the telco network in various places. This brings some advantages to a telco. So at the moment, the activity of upgrading the mobile core and other parts of the network, very big project. It means it takes months of planning, months of testing, and culminates in a long planned outage over a weekend. That's a very intense process. As we get the software running in pods in Kubernetes, we can start to take advantage of more cloud native tools such as Jenkins and Argo to do continuous, we don't quite call it integration because we're not really doing the coding. So we don't commit things back to a Git repository, but we do continuous testing, automate all that testing, and then we do continuous deployment. So you can do Kubernetes rolling upgrades for your pods. And then again, when we become fluent in that, the activity of upgrading your core is much less nerve-wracking, and it become routine, and internal distractions gone away from the telco then, and you can look at you can put more attention on your customers, make sure they're getting the service that they need. And also, the telco involves a tremendous amount of configuration. So that's could be, it's quite clunky and uses some very difficult to parse by a human domain-specific languages. We'd hope that we can move to GitOps for those, store them in a GitOps repository, and life will then be easier and again less fraught when we're configuring the network, because we can do a rollback if something goes wrong. Another big topic then is observability. So if you reflect back to the network that I portrayed before, there are lots of information to take in to monitor it. We have a particular style of doing things at the moment in terms of fault and performance monitoring. But as we get the cloud native software and multiple types of services running concurrently over multiple layers, so we'll have compute clusters, all the Kubernetes control plane, the application pods, and then the interior behavior of those applications. That's a lot of information to ingest and understand if the network functions are working properly. So we need to move to observability approaches, take those on board from cloud, and use the tools that we've seen earlier on the presentations, such as Prometheus and Jaeger, InfluxDB, Grafana, etc. So to give a quick example, in each network function cluster, we could have, say, Prometheus running under an operator. It has a standard configuration. It can also read metrics from the network, custom metrics from the network function, and then drive automation of that network function. So if, say, there's a sudden surge in demand, say there's a sporting event on that puts strain on a cell site that's running under Kubernetes, then by automating right within the network function cluster, we can have a scale out operation to add more pods to enable the network function to absorb that spike in load. And then someone in the network operations center doesn't have to do something manually. So really strong levels of automation expected in the network in the future. And then we obviously need to be able to make that data accessible and explorable. So that's something we're looking at a lot at the moment. Some of the protocols for managing these existing networks are pretty archaic. So you get your performance data with a time resolution of 15 minutes, about an hour after anything important's happened. So thank goodness it's changing. So we want to move to telemetry through gRPC, GNMI, encoded as Google Protocol buffers. And that way we can get information at the time resolution that allows us to automate using machine learning rather than more rules-based automation. And also the data is still useful. So lots of the problems we might see in the mobile core, for example, there could be a jitter, as we say, a frequency of a few milliseconds. So we need that much higher time resolution data to identify those problems. And at the moment, you need to buy very expensive probes to augment your core. Other things that are happening, I don't know if you've heard of network slicing. Anyone heard of network slicing? Very similar, yes. So network slicing is a way of providing a portion of your network, such as say a subset of the spectrum in a certain region to another business or organization, and then they can run their own private network on that spectrum. Or it could be, say, for gamers, you can have a dedicated network slice with a particular quality of service for gamers. So this means, again, there'll be multiple layers of service on your network, and we need to be able to configure that using intent-based declaration of the configuration rather than having to go through every detail of code by hand. So that's really important, and we take inspiration from the way Kubernetes and its declarative way of working operates. So auto-generated manifests and config we expect to come to telco. And then last but not least, really important, mobile and fixed networks absorb enormous amounts of energy to power them. That obviously is both expensive and generates a lot of CO2. So we're very keen to reduce the electricity bill and the CO2 emissions. Fortunately, lots of telcos now have good agreements on renewable energy providers, but still anything we can do to reduce the energy consumption is important. So again, harking back to these network functions, we want them to be both horizontally scaling. So if at night, say there's not much happening on the network, all those functions can shrink right back in. And then some of the hardware can automatically be turned off overnight, saving power, cooling, etc. And also vertical scaling. So the default pod size we don't want that to be over-specced. So using too much compute by default, and we want to employ technologies, probably machine learning, to reduce the scale of the pods. Because when you get in these network functions, that the supplier is probably quite conservative at first in the resources that they require. Okay, now there are a few things happening in the industry to standardize this. I just want to highlight them. So around standardizing Kubernetes for telco, don't know if you've heard of the Linux Linux Foundation networking project, Anaket. That's defining the reference architecture for Kubernetes for telco. So you get a reference architecture, also defines certain performance specifications and tests that can be done to validate that a Kubernetes flavor is right for telco, and also that the software that's running on it is right for telco. So a number of my colleagues are working directly on that project. Now, CNCF, obviously, we use many of the graduated projects. I can't really touch on them all, but projects in other areas like storage, security, all really important to telco use cases. And then we have Nefio, another Linux Foundation networking project. This is a bit more general, so it's looking at the full, bringing the full cloud under the remit of Kubernetes-based declarative configuration. So Anaket would be a subset of Nefio. So you request a cluster for your telco, and that can be ordered through Nefio, which then uses templates from Anaket. And another big area of development is the telecom infra project that has lots of sub-projects, such as Open RAN, but also in other areas such as fixed broadband, optical routing, and packet transport technologies. That's also a heavy consumer of cloud-native technologies. So thanks again to the cloud-native community for those. This talk was going to be, if you can find it, an extended trailer. Oops. Try again. It's hiding my, there we go. It was going to be an extended trailer for KubeCon Cloud Native Telco Day, where there's much more in-depth presentations on some of the subjects that I've been talking about. My colleagues, Tom Kivlin and, have I got the right screen? I think so. My colleagues, Tom Kivlin and Ricardo Gasparetto Story, are a couple of the speakers on this project at 10:20. But unfortunately, it looks like it's already sold out. So if you go into KubeCon, unfortunately, you won't be able to get in there. But I'm sure we can get Tom or Ricardo back to a future presentation if that's of interest to you. So I think that's it. And I'd just like to say thanks to the Cloud Native community for all the useful technology that you're supplying to us in the telco world. Thank you.
We have a bunch of questions already,
Oh, no.
So you might as well just rattle through them.
Okay. Are you developing the code behind disaggregated network functions? We're certainly experimenting in that area. It's not something we're directly taking on just yet, but we do have developers and R&D looking in that area. Do these functions run on the edge or do they run in the cloud? So first of all, they can run in telco's private cloud, so running Kubernetes in our own data centers, or they can run in the public cloud. So lots of telecommunications vendors provide both options. Do they run at the edge? Probably not the major 5G core ones, because they're catered for big use cases for hundreds of thousands of subscribers. But as the automation comes along, specialist use cases for private networks and other services, network functions could run at the edge. Oh, too many questions. Are network functions virtualized on Kubernetes, or are they hardware appliances? So at the moment, the majority of mobile core functions for 4G are virtual network functions. So they're virtualized, but not containerized. There are a few appliances kicking around still. The big map that I showed earlier, those are specialist appliances still for the majority. There are some virtualized functions for things, technical term root reflectors, if you've heard of those. where am I? What are the difference between the, oh, sorry, I'll go to the top one. If one wants to experience a fully fledged 5G core network, core to edge, where should one go to? Well, the UK later this year. I think there are some deployments already in proof of concepts, but Vodafone's 5G core in the UK goes live later this year. Why were the MOB dots in the Nigeria network mapped than anywhere else? Not entirely sure. The reason for that, I suspect it's because Vodafone are one of the countries that Vodafone partnered with had already had points of presence in Nigeria, and Nigeria has lots of multinational companies running in that part of the world. So I suspect that's part of the funding for that infrastructure. What is the difference between the red and blue lines on the infrastructure map? Can I remember? I think it was the difference between the public and private network that I mentioned earlier. So you've got the public AS1273, which is part of the public internet, and the red lines are the private network.
We're kind of running out of time here, and the questions are coming in faster, I think, than you can ask them. So basically take one more and then go and
so what routers do you use? That's probably the easiest one to answer. So, so big name vendors such as Cisco, Nokia, Juniper for the core, Huawei too, and a few other smaller vendors. Depends on the circumstance. And then the CPE space for enterprise customers, there's a much bigger spread of customer companies that can provide kit.
I'm going to wrap up there, and then if you have more questions, come and chat to Richard afterwards. Thank you. Alrighty, thank you so much. Thank you for playing along as well with our questions and our polling. That concludes our events for this evening. We'll be back again on the first Wednesday of May. Hopefully I'll see some of you at KubeCon as well, if you're going to be there in Amsterdam. Otherwise, have a great night. We're going to go down to the Conductor, that is the pub just outside this building, if you want to chat more. Thank you so much. Have a good night.